Misha, what are you doing? Hello, welcome to our Thursday Algebra 2 stream. It's May 12th. May 12th. And hey, I need you to move. So I don't want to roll over you. Hope he's sleeping under me. Pulling up the chat. Where we get something showing up. And we're going to talk some more about trig functions. We're going to use the textbook and the student journal that's in the Dropbox folder, which would be useful. We have those out. Really quick. Eating on stream, probably not the best, but it is what it is. So first thing, on Thursday last week, we talked about radians and the standard position for an angle in the coordinate plane. And I mentioned the unit circle, but we didn't really do anything with it yet. That's on purpose. We're going to be right here for now. And we're going to talk about the unit circle. So, unit circle, oh, we got lag. Hold on. That's better. Okay. So we have the unit circle, which is a circle in the coordinate plane where the radius is 1. With a radius of 1. This makes our calculations for coordinates in this unit on the unit circle really simple. And it gives us kind of a baseline for some trig functions. And we're going to have angles, theta, off of here in all 4 quadrants, right? So we have quadrant 1, 2, 3, and 4. They go counterclockwise around the circle. And we can calculate these coordinates here based on a couple of things. The angle, I'm gonna redraw this. Okay, so this is the basic picture of what the unit circle is. It's called a unit circle because the unit of the radius is exactly 1. Here's my x-coordinate and y-coordinate. I'm just kind of zooming in on the first quadrant of our unit circle. Here's our radius of 1. Here's our angle theta going off or whatever. Okay, and right here, this coordinate x comma y is part of a triangle, a right triangle in the unit circle. Okay, and this height here is the y value, and this is x. It's less than 1. And we're going to use this. This is also radius 1 to help us with some of our trig functions. All right, so we have sine, cosine, tangent, and then cosecant, secant, and cotangent. Sorry, I mixed them up sometimes. Okay, so that's our unit circle. And we're going to use this to help us with evaluating some trig functions. Okay. Now, we have some general definitions. This theta could be in any quadrant. So if we go and look in our student journal, that's the wrong. There we go. Student journal. This is like the start of like the note taking. This is page 254 in the student journal page in the Dropbox. Okay. What we're doing here is we're using this circle and this degree, which could go all the way around. And we're use the Pythagorean theorem here, because it's a right triangle. A squared plus b squared equals c squared, except here we have x squared plus y squared equals r squared. For this triangle right here. And then these functions are defined as follows because it's a right triangle. So we have sine of theta is opposite over hypotenuse. So it's the y value over the radius. Now this works for any theta. Before in geometry, we would have done only acute angles. They would have only fit here in this first quadrant. But we can talk about this angle here that's bigger than 90 degrees and puts the triangle in the second quadrant. Okay. So we have sine, cosine, tangent. These are all the same as they were before. They're not redefined. We just kind of relabeled our triangle. Okay. And then we have the cosecant, secant, and cotangent, which are the same functions. They're just these flipped over, right? Okay, and then we talked about the unit circle. It has a radius of 1, so we get x squared plus y squared equals 1. If you type this into Desmos, it'll make a circle. This is the function for a circle. Center 0, 0, and then radius 1, so the center's here, and then the distance from the center, the center from here, 0, 0, to the radius is 1 unit. It can be whatever. That unit could also be, it could be 1 unit in a certain measurement and many different sizes of units at different measurements, which lets us apply the unit circle to any situation. Okay. And so, because it's a unit circle, the functions here do some really interesting things. These 6 functions, everywhere there's an r, we would put a 1 there. So sine of the angle is just whatever the y value is. It's just whatever the height is. And cosine of the angle, the r is a 1, so it's just the x value. It's how far left or right we went. Okay. So that's this here. It's really useful because the r is just 1, which is why we make it a unit circle. That's why it's useful. Okay. So what we would do with this is, sorry, I won't be on that. Oh, shoot. We're going to do this. So we're going to do some examples here that involve solving for pieces of this unit circle or just a circle in general with the angle. Okay. So we're going to do this first example in the textbook. Looks like this. Okay, so it says let -4, 3 be a point on the terminal side of an angle theta in standard position. So remember, standard position means one side of the angle goes along the x-axis. The terminal side is where the rest of the angle is, and 4, 3 is a point on this terminal side. So we have -4, 3. And then we have this right triangle with the r. Okay, and then theta is some obtuse angle. So that would look like this, right? I redrew it. Evaluate the 6 trigonometric functions of theta. So here's what we're going to do. We need to know what r is. And so we're going to use the Pythagorean theorem, a squared plus b squared equals c squared, to solve that. This triangle can be rewritten as a -4 here and a 3 here. This is really just 4, right? So in our Pythagorean theorem, we get r squared equals x squared plus y squared. Okay. And then we just substitute x and y into here and solve for r. So r is going to be the square root of 4 squared plus 3 squared. And I change it to just 4 because when we square the negatives just go away. Okay. So r here is going to be the square root of 0.5, which is 5. So our radius is 5. So then we can evaluate all the rest of these trig functions for this angle. We're not actually finding the angle, though we could use the inverse functions to find that, but we're just saying, okay, I know that I can set up the function. So sine is going to be opposite over hypotenuse, right? So we're going to use SOHCAHTOA to help us remember these things. Sine is opposite over hypotenuse, so we're going to do opposite, it's the 3, over the radius, which is 5. So this is 3 over 5. Now it's not really opposite the angle, but it's the opposite side of the angle. side here. It's the vertical. And then cosine of theta is going to be adjacent. It's going to be 4. Now, it's a negative 4, right? So this is a negative 4 over 5. Tangent of theta is opposite over adjacent, so it's 3 over the negative 4. Cosecant is this fraction just flipped over. And secant theta is just this fraction flipped over. And then cotangent is this flipped over. It's the reciprocal of whatever the fraction was. So once you figure out these three, you just flip them, and it's the cosecant, secant, and cotangent functions. Okay? So we found all the trig functions. We didn't find the value of theta here. But if we knew theta and we plugged sine of theta in, we would get 3/5 in that calculator. Okay? So these are the values of the trig functions of the angles. We don't know the angle. We don't need to know the angle because we have the functions. Okay? We'll talk about the unit circle. Do that. Okay, there are some angle relationships that do matter. We want to go back to the student journal page. The angle relationships. So that looks like this. Okay, we have a reference angle, which means it's the closest angle to the terminal angle and the standard angle. So when we're drawing our standard angle in a coordinate plane, part of it goes here on this side, right? So it would start here, and then theta, it would point like this, and it matches up with the x-axis. And then this is the terminal side. That's where it is. Okay, so that's theta. But we have another angle to help us. That's the reference angle. It's this angle here. So theta prime, we call it the reference angle. And that angle is useful because when we draw this triangle over here, this angle doesn't really tell us very much. Chat's not this big, but I'm going to focus on this. So this reference angle is just this theta minus 180, or pi minus the angle. So theta prime is 180 minus theta, or pi minus theta, depending on if you're using radians or degrees. Remember, radians just measure the distance around the circle, the distance around the outside of the circle. Okay? So this would be the reference angle if it was in quadrant 2. If it's in quadrant 3, it's going to also match to this thing. So if my angle is this theta, then the reference angle is going to be this, because it matches to the closest 180 on the x-axis. It doesn't match to the next vertical line. It matches to here. So this would be our reference angle. And then if we're in quadrant 4, so if this angle goes all the way this way, then this is going to be the reference angle. It's just going to kind of complete the angle to the closest 180 degrees, or the closest pi degrees. Here we would do 360 minus theta, or we would do 2 pi minus theta, depending on if we're in radians or degrees. Okay. Now the reason we do this is because this reference angle is going to be easier to utilize than the big angle. It's easier to think about because it's smaller. Okay. So here in the student journal, we have all the same diagrams with formulas. Okay. It talks about what the reference angle. reference angle is. Here about this. No, you would just do Q. Like, I don't want you to do this 7 here. Don't need you to do this, but I do want you to be able to do these things. So we'll do those 2 examples, and I think we'll be done for today. So 5 here. We have our coordinate plane, and we're going to sketch negative 310. So each of these is going to be 90 degrees. This is 90, this is 180, this is 270. So 310 is somewhere over here. Oh, but it said negative 310. So if we're doing negative 310, we go the other way. Sorry. We're doing negative degrees, we go this way. So we go negative 90, negative another 90, negative 180, negative another 90, that's 270, and then negative another 40 degrees to look like this. So negative 310 degrees. We went in the negative direction, which means our angle here, this is theta. This is the reference angle that we want. Okay, so we just say, okay, what's 360 minus 310? Well, that's a 50-degree angle. So this is the prime. That's our reference angle, is 50 degrees. Should be simple enough. Okay. Okay, I think that's it for today. In class we would have done these things a lot differently. That's really all I want to do. Trying to make the lesson shorter, focus on the important things. The important things here are the unit circle. Right, so finding the reference angle, I want you to be able to do that. And then the unit circle. All right, what's this thing? It's a radius of 1. We use it to find x and y, which we will do more of on Thursday and so on. Sorry, you can't see it. My face is in there. Okay, so that's it for today. We have a few additional, not the same as continue to get me stuff in, assignments. I graded on Sunday, I think. And so there's a few assignments I've gotten since then that haven't been put in, but most of everything has been graded. And if you're a senior, right, you have till May 21st. We've got 9 days. We're running out of time. Great. Okay, I think we'll do a Zoom call on Friday again. Just a short one, just like check in, say hi, answer questions if I know the answers, kind of things. Talk about math if people have questions. And that's it. I will see you guys on Thursday. And I'm going to wake the puppy up. Oh, she's getting big. She's getting heavy. Her ears flopping over. She's tired. Yep. All right. I will see you guys on Thursday. And I hope you have a good week.